Hey guys, back for another one of these. Today we got stretches and shrinks. Yesterday we did some translations left and right and up and down. Now we're going to stretch and shrinks the same graph. So let's see what it looks like. Okay, first of all, horizontal. You got to be able to recognize which is which. A horizontal stretch or shrink happens when there's a number inside with the x. And what happens is the horizontal is a weird one. If the number is bigger than 1, it's actually a shrink by the reciprocal. That 1 over a right there is the reciprocal. If it's less than 1, it's actually a stretch by the reciprocal. So like, let's say that a right there is 1/2. Like, say you got a 1/2 x, that'd be a horizontal stretch by 2. If it was a 2x inside, like this, like a 2x inside absolute value, it'd be a horizontal shrink by 1/2 by the reciprocal. So horizontal, the number with the x has to be multiplied and has to be inside with the x. Okay, now let's go to vertical. Vertical is just the opposite. If you look right here, the a is outside the function. Okay, it's in front, but it's outside. And this one's a little bit easier because if a is bigger than 1, it's actually a stretch. Right here, if a is bigger than, like if it had been 2x, let's say 2, like that, outside, that's a vertical stretch by 2. It makes it twice as steep. If there's a 1/2 in the front, if it's less than 1, it's actually a vertical shrink. So let's keep them straight. The horizontal stretches and shrink are reciprocals, and they're backwards of what you think. So like the x and the numbers inside. Numbers inside, bigger than 1 is a shrink. Less than 1 is a stretch. Vertical, greater than 1 is a stretch. Less than 1, shrink. Okay, so I'll give you a good way tomorrow. We're going to do some gestures, keep these straight. I know you can't wait for that. All right, do a couple of problems here and we'll be done. Let f of x be that function, absolute value function. Write function g, so I'm going to start with g of x, whose graph is a horizontal shrink of the graph by a factor of 1/3. Okay, now that 1/3 then has got to be inside the absolute value because it's a horizontal. And we got to remember that a horizontal shrink is reciprocal of what's inside. So if it's going to shrink by 1/3, that really means I'm putting a 3 inside that absolute value. So basically I'm replacing the x with a 3x. So I'm going 3x minus 3 and then minus 5 outside. And that's the horizontal shrink. All right, now part B says write a function h. So I'm going to h of x, whose graph is a vertical stretch by a factor of 2. Now, vertical stretch set of numbers on the outside, and there's no reciprocals in a vertical stretch or shrink. So they actually put the 2 out there, and inside I still have the x minus 3 and minus 5. And that's it. Okay, I'm just being honest here. I just stopped the video for a second because 4 people walked in here. So I'm hoping that was good on those 2 problems. So go one more slide. All right. Says let the graph of g be a vertical shrink. So again, graph of g of x, be a vertical shrink by a factor of 0.25. By the way, that's really 1/4, followed by a translation of 3 units up. Okay, so the last thing you're going to do tomorrow in class is you're going to combine transformations. Like they may have a stretch and a translation, like up or down or left or right. So this one, because it's vertical, the 0.25 or 1/4, whichever one you want to do, goes outside, and it's just an x. There's no absolute value on this one, so I'm just going to put the x there. And because it's 3 units up, I'm just going to put a plus 3 because remember, up or down is exactly like you think. And that's it, guys. Hopefully not a bad day tomorrow. That's all we're really doing. Vertical stretches and shrinks, horizontal stretches and shrinks by reciprocal. And keep in mind all the translations we did in class today. You should be fine. See you tomorrow.